Hello students. Welcome to today's class. We are going to talk about force fields. Before we proceed with today's lesson, remember, in our previous class we discussed the following. The method used to identify a charged body. The distribution of electric charges. The various methods used in the storage of electric charge. By the end of this lesson, you should be able to identify different types of force fields. Describe the properties of a force field. Now, let's start by explaining the term field. In physics, the term field refers to a region in space where a particular physical quantity can be measured, like temperature or pressure. But today, we are focusing on a specific type of field, which is the force field. A force field is a region in space where an object experiences a force due to some properties like mass, electric charge, or magnetic effect. Here's an example. When a magnet pulls a screw from a distance, the screw is inside the magnetic force field of the magnet. You didn't touch it, but a force acted on it. That's the beauty of force fields. So, remember, a field is any measurable effect in space, while a force field is a field that causes forces on objects without direct contact. Now, let's talk about the various properties of force fields. Force fields have both magnitude and direction. They are produced by objects and affect other objects. An example is, a gravitational field is produced by mass and affect other masses. Force fields allow objects to interact without direct contact. Example. The Earth pulls the Moon with its gravity, even though they don't touch. Different types of force fields follow different laws. Example. Gravitational field follows Newton's law of gravitation. Electric field follows Coulomb's law. Magnetic field follows Ampere's and Faraday's laws. Good job, students. You are doing great. There are three common types of force fields, which are magnetic field, gravitational field, and electric field. Magnetic field. A magnetic field is produced by magnets or electric currents. Iron filings are commonly placed near a magnet to form curved lines, thereby showing the field's shape. Note: iron filings are very small pieces of iron that look like a dark gray powder. Gravitational field. Gravitational field is created by any object with mass, like the Earth. It pulls objects toward it. That's why things fall when you drop them. Electric field. Electric field surrounds electric charges. For example, if you rub a balloon on your hair and it sticks to the wall, that's the effect of an electric field. In today's class, we are going to talk mostly about magnetic field. So, what exactly is a magnetic field? A magnetic field is the region around a magnet where a magnetic force can be felt. Even though we can't see it with our eyes, we can see its effect. Like how it moves a compass needle or pulls iron objects toward a magnet. When you sprinkle iron filings around a magnet, they arrange themselves in curved lines. These are called magnetic field lines, and they show the direction and strength of the magnetic force. Here are a few key things to know about magnetic fields. Magnetic field lines go from the North Pole to the South Pole of a magnet. They never cross each other. The closer the lines, the stronger the magnetic field in that area. And guess what? The Earth itself is a giant magnet. That's why compasses always point north. They follow the Earth's magnetic field. Now, that's science in action. Magnetic fields aren't just for science classes, they're everywhere in real life. They have many practical applications in our everyday lives and industries. Here are some common and important applications of magnetic field. They power electric motors in fans and blenders. They are used in speakers to make sounds. They are used in power plants to power electricity. Special trains float above the tracks using magnets, so they go super fast. Even MRI machines, in hospitals, use magnetic fields to scan our bodies. I have 2 assignments for you to work on. Number 1. What is the main difference between a field and a force field? Number 2. A student rubs a balloon on his hair and it sticks to the wall. What type of force field is responsible for this? What object created the field? You are doing great. Before we end today's class, let us summarize on what we learned. In today's class, we learned that force fields are invisible regions where objects experience forces without direct contact, like magnets pulling iron or balloons sticking to walls. We also learned that force fields have direction, strength, and follow scientific laws such as Newton's, Coulomb's, and Faraday's laws. So, keep exploring and stay curious, because physics is not just in books, it's everywhere around you. In our next class, we are going to talk about gravitational field. Thanks, and goodbye.